Okay, well, I'm going to do another podcast example here. What we're going to do is we're going to calculate a molecular formula given an empirical formula and a molar mass. Keep in mind that whenever we're calculating a molecular formula, we have to be given these two things, an empirical formula and a molar mass, or at least given enough information to calculate an empirical formula. But we always have to be given the molar mass. So here's the example we're going to do. What is the molecular formula of a compound with an empirical formula of CH4N and a molar mass of 60 grams? In class, we went ahead and we saw how the molecular formula and the empirical formula are related by this number n, and we saw that the masses, the molar mass and the empirical mass, are both also related by that same factor n. And we came up with these two equations that we have here, that the molecular formula is equal to n times the empirical formula, and that n is equal to the molar mass divided by the empirical mass. Keep in mind the empirical mass is nothing more than the molar mass of the empirical formula. So empirical mass is the molar mass of the empirical formula. Okay, we're ready to go ahead and get started here. First thing I'm going to do is I'm going to identify my molar mass. Right here we have a molar mass of 60 grams. That's going to become important later. I know that I want to figure out the molecular formula. I'm going to have to calculate n because I don't have that, so let's go ahead and get started with that. We know that n is going to be equal to the molar mass, which we just found as 60.0 grams, divided by my empirical mass. Well, we don't have that empirical mass yet. What we're going to have to do is take that empirical formula and calculate that. So let's go ahead and do that off to the side here. We have CH4N as my empirical formula. So to calculate that empirical mass, I would take carbon, hydrogen, and nitrogen. For carbon, we've got 1 times the molar mass of carbon, which we can look up on the periodic table. So we'll go over here, we'll take a look on the periodic table. There's carbon right there. Right there, 12.011 grams. Again, we're only going 2 decimal places off of everything on the periodic table, 1.01. We're going to always use 1.008 for hydrogen, and then the last one is nitrogen. Again, to 2 decimal places, that's 14.01. So that's where we're getting our molar masses from. So let's go ahead and go back, and we go 12.01. That's going to be 12.01. And then hydrogen, we've got 4 of those, so it's 4 times 1.008, which is going to be equal to 4.032. Again, this is all in grams. Anytime we're taking anything off the periodic table, it's in grams. And then we've got 1 times 14.01, which is equal to 14.01. Again, that comes from our subscripts here. These guys are understood to be 1 and 1 because there's nothing written there. That's where this and this come from. And then, of course, that 4 goes here. All right, let's go ahead and add these up. I get 2, 5, 0, 8, 10, carry that, and I get 30.025 as my empirical mass. This again is the empirical mass, the molar mass of my empirical formula. So that 30.25 goes down here. Oops, 0.52, sorry. We'll go ahead and divide that. I'm going to grab a calculator. Turn that on. There we go. And I've got 60.0 divided by 30.052. And that is, I need 3 sig figs here, so that's 1.996. That's 6 is going to cause the 9 to round up to a 0, and that's going to round up to a 0. So really, I've got about 2. So n is equal to 2. That should always come up to be a nice sharp number there, no decimals, very close, 1.99, 2.01, something that'll round nice. So now we're ready to go ahead and calculate our molecular formula. That molecular formula is going to be equal to n times the empirical formula. So we're going to go ahead and plug in. We got 2 times our empirical formula of CH4N. So that means our molecular formula will be C2. I just distribute this 2 to 2 times 1 gives me C2. 2 times H4 gives me H8. 2 times N1 is going to give me N2. And that is my molecular formula.